Hi all of you, good afternoon. Some of you who have come for the practice test for enrichment, go downstairs. Anybody in the class? Last time 4 or 5 of you were here by mistake. All of you are climatology students. Anybody for enrichment? Yeah, practice paper. Okay, 3, yes. So anybody offline has come for the test, go downstairs. Okay. And online students, if you are part of the class right now, make sure you see the questions and do it afterwards maybe. Yes. ठीक है. जब अंदर आए तो पूछ लेना कि टेस्ट के लिए आए हैं कि क्लास के लिए आए हैं. पिछले बार 5-6 बच्चे यहीं आ गए थे गलती से, नीचे ले जाना. Yes, Soumya, we'll do that. I had a plan to do it today, but something has come up. Right then, we start off. Climatology, and we have been discussing the atmosphere. We discussed what is the origin, what is the importance of atmosphere. We have discussed the composition, and we were discussing the structure. How is the atmosphere arranged? Okay. No, Nishant. For all of you, tomorrow being Gandhi Jayanti, you will not have a class tomorrow. Okay? Yeah, you don't have to look so happy either. At least when I'm looking and talking to you, थोड़ा सा मेरा भी मान रख लो, look sad. Yo, sir, no. Oh shit, yaar. Okay, that types. नहीं रखता कल. Gandhi ji is very important for all of us. Okay. So we have done the origin, how the atmosphere has evolved. The atmosphere as a consequence of nebular accretion, consequence of tectonic processes, consequence of biological process, and also consequence of certain chemical reactions. What is the origin of the atmosphere? About the importance, the atmosphere supports life, the atmosphere supports gaseous cycles, the atmosphere protects us from asteroids' impact, and I said the atmosphere also plays a very important role in regulation of the temperatures. If the atmosphere was not there, the Earth would have more extremes of temperature, like we have seen that for Mercury. The sun facing side, temperatures are in excess of 430 centigrade. The side away from the sun, it's minus 200 degrees centigrade almost. So with the atmosphere, the heat can be trapped, and that way the temperature regulation is possible because of the atmosphere. So this you understand. Composition, there are major gases, there are minor gases, there are certain permanent gases, and we also have lot of variable components. The variable components are water vapor, carbon dioxide varies now because of human aspects. Otherwise, dust particles vary. We also have trace gases like neon, like helium, like a gas called as krypton, but they are very, very less. The major ones, 99.9% of the atmosphere is nitrogen, oxygen, argon. इसमें you can add CO2 also. So ये मिलाकर almost 99.93 percentage of the atmosphere. And then we made a point here that these three, although they are the bulk of the atmosphere, they don't play significant role in the temperature regulation, and therefore they don't play a significant role in the climatic processes of the earth. Any climate process that we have, why winds move, why we have rainfall, why we have cyclones, why we have air masses, why we have fronts, all are part of the consequence of that the atmosphere has heat variations. Some part is cold, some part is warm. The daytime it's warmer, nighttime it's cooler. The polar areas are cooler, tropical areas are warmer. The difference of the temperature is what creates almost all the processes of the environment and the atmosphere. So these three are not as important. The more important components for atmospheric processes are carbon dioxide, we have water vapor, we have ozone, even the dust particles, the salt crystals, they play a very important role in how the atmosphere starts behaving. Why we said? Why? Because these are the greenhouse substances. Greenhouse का मतलब होता है something which can trap the heat energy and not allow the heat to escape very easily from the atmosphere. So they play a role in all the processes we have of the atmosphere and the climate. Okay, I think this part is fine with all of you. Right. So atmospheric composition and the role. And then we were discussing the structure and the arrangement of the atmosphere. We made 2-3 statements. We said number one, the atmosphere is a mixture of gases, but it is not a random mixture. Mixture generally implies that it can be more random, more variations. Atmosphere is very well mixed. It's so well mixed. We talked about a principle called as the principle of constant proportion in how the gases are part of the atmosphere. Whether we have more atmospheric gases or less gases, the ratio between the gases is fixed. Nitrogen is always 78%, oxygen always 21%, argon always 0.93%, and so on. So atmosphere is a mixture, but it is very well mixed, at least very well mixed for most of its composition. There is a part above 80 kilometers where we say that the atmosphere has layers in terms of the molecular weight or the ionic weight of the gases. Within 80 kilometers, there is no such differentiation. Within 80 kilometers, okay, the atmosphere does not separate out in terms of the molecular weight of the gases. Okay? Otherwise, I mentioned that to you. You look at nitrogen molecule, that is 28 units of weight. Oxygen molecule is 32 units of weight. Water vapor, okay, this is 18 units of weight. You look at carbon dioxide, it is 44 units of weight. If there was molecular segregation, then the lower layer should have had this, then the layer should have been this, then this layer and so on. But ऐसा नहीं है. Okay, so the surface is here for 80 kilometers tak or 100 kilometers tak. The gases are very well mixed. The gases, okay, are mixed in some proportion. So this air acts like we said a unified gas. It's almost like one single gas. And we said this gas obeys the gas laws. Okay, there are 4 or 5 gas laws. Okay, it obeys those gas laws like it is one gas. But the moment I go above, okay, यहाँ पर the molecules and the atoms and the ions separate out. The lowermost layer has nitrogen molecule layers. Then we have oxygen ionic layer. Then we have helium layer. Then we have a hydrogen layer. So there is some segregation in terms of the weight beyond 80 or 100. Okay, but then the amount of gases बहुत कम है यहाँ पर. I explained that to you, right? If you look at the composition of atmosphere, by about 30 kilometers tak, 99% of the atmosphere is over. Okay, beyond 30, 40 kilometers, you don't have much atmosphere left. That's why I said for much of its height, okay, much of the height within which we have atmosphere, the mixing is very good. It's almost like one single gas. Rarefied, umang rarefied का मतलब होता है it is not dense. Okay, dense opposite is rarefication. So the lower layers are dense, the upper layers, the molecules have spread out. It's more rarefied. Less dense, the molecules are farther away. They are spaced at a distance. The upper layers are rarefied, the lower layers, the atmosphere is very, very dense. Umang, fine? So, how does the layer look like? I said there are 3-4 schemes are looking at the layers. One is the layers in terms of the density stratification. Okay, this is not in terms of molecular weight. It's in terms of okay, lower part having more molecules while the ratio of the gases remain the same. Okay, and you go upwards, the atmosphere becomes more and more rarefied. The atmosphere has more and more lesser amount of molecules. So the graph, I hope you remember, okay, at the sea level, it is 1 atmosphere pressure. At around 5.6 height, it is half atmosphere pressure. At around 16 kilometers, okay, it's only 0.1. Okay, 90% is over here. Okay, so 5.6, 16 kilometers, यहाँ बीच में 11 to 12 kilometers पे 75% is over. Okay, so this is the graph of the density stratification of the atmosphere. And we said that this density stratification happens because, okay, the air has some weight and air is also compressible. So lower layers have the weight of the entire atmosphere. The lower layers compress a bit more. You go above, there is lesser, but this weight will also compress a bit more. You go above, it becomes even lesser, but yet some compression. So it is not a linear change of pressure. There's some almost like an exponential change. Ritik, that's how we have observed. इसमें why नहीं पूछते हैं. Okay, that is how the atmosphere and the pressure pattern, okay, manifests. Okay, so this is a property of the air. Properties when we don't ask why it is like that. Why is the weight of iron 13.5? That's how it is. Why does water have a density of 1? That's how it is. Why does hydrogen burn with a pop sound? That's the property. The atmosphere's property is that this is the pattern of the vertical variations in the pressure and relative compression. So above layers are rarefied. Okay, so this you understand. The second scheme we talked about was in terms of the a relative mixing of the gases. The lower layer, we have called this as the homosphere, and the upper layers we have called as the heterosphere. I think that names also explains why they are called so. Heterosphere as in not good mixing, heterogeneous, and homosphere as in homogeneous. The mixing is fairly uniform. Okay, so this you understand. The third discussion we had started with was the pattern or the layering on the basis of temperature patterns. Okay, all the three schemes of atmosphere structuring are different ways of looking at how the properties of atmosphere changes. So one was based on density stratification, one was based on relative mixing, and the third is based on the temperature properties. Okay, yahan tak any doubts, anybody? Any clarification you seek? Online, offline? Any doubts? Yes, tell me. Atmospheric wind, window. यहां तक कोई डाउट है? वह मैं शुरू करूंगा अब इसमें. Anybody in doubts on atmosphere's origin, atmosphere's importance, atmosphere's composition, and the layering of the atmosphere in terms of density or in terms of the mixing? All good here? All fine? अच्छा, ठीक है. Let's start off with, and this is the more important part. The other two is not as important, but you should know this. But this part is more important, and quite a few questions are asked almost every year in your GS prelims paper. हर बार कुछ ना कुछ क्वेश्चन पूछेगा on atmosphere, radiations, IR waves, ultraviolet radiations. They ask something or the other. Okay, so let's discuss this one now. Now, couple of points. The first point is that Earth receives much of its Earth bolo या atmosphere bolo, much of its heat from insolation. However, the insolation does not heat the atmosphere directly. Whatever temperatures we have of the atmosphere, the root source of the energy is insolation. Insolation is a short form of incoming solar radiation. So I hope you all know this. Insolation is the energy coming from the sun. Okay, so I said the atmosphere receives much of its heat from insolation. Okay, because the other source of heat are even the biological processes, right? When I am respiration going on, some of my body heat also gets transferred to the atmosphere. Volcanic eruptions are also source of the heat energy. But if you look at the atmosphere, the primary source of energy is not tectonic source of heat and not the biological source of heat. The main source of heat is insolation. But then we said insolation does not heat the atmosphere directly. If the heat was directly from insolation, in that case, the upper layer should have been warmer. As I go further away, this should have been cooler. As I go further away, this should have been more and more cooler. And on the surface, it should have been the hottest. It should have been the coolest. ऐसा नहीं है. Okay. The energy comes in, the energy passes through, hits the earth, earth absorbs, and earth also radiates back. Now this also is a property of the earth. If earth was continuously absorbing and not releasing heat, earth would have collapsed by now. There is a mechanism by which earth receives energy and also earth radiates back energy. There's a term in physics, we call this as black body principles. So black body is a body that okay, which can receive energy and also radiate back. That's how the bodies maintain the energy. If they only receive, if they keep on absorbing, it pura phat jayega. Okay, and Earth has been receiving energy for more than 4.56 billion years. So by now, Earth would have been over. But there's a mechanism by which Earth receives and Earth will give out. The energy coming in is high energy radiations. Coming in are short wave radiations. These are more powerful ones. They can pass through without getting absorbed. But when the Earth starts losing heat, the loss of heat is low energy. The loss of heat is in the form of long wave energies. Long wave energies are not as powerful, so the atmosphere can start absorbing. So more energy absorbed here, so this part is warmer, you rise up, it becomes cooler, it becomes a bit more cooler, and then some changes happens. So the insolation is the primary source of all energy of atmosphere, but insolation does not heat the atmosphere directly. Atmosphere is heated by the outgoing radiations from the Earth. I think this part is fine, all of you. And one of you asked me yesterday, so why is the sun releasing more energy? And why is, when Earth receiving, reading out, why does this release low energy? There is some transformation happening. It's like, it's possible, I get the income in some form, but when I'm giving out, I give the money in some other form. So I receive my income in terms of rupees and cash, okay, but I may be giving to my children in the form of food, clothing, shelters. So the form can change. And why it changes here is because of the temperature. The sun, the outer layers are at almost 6,000 centigrade. Surface layers of the Earth are in the range of 15 to 16 degrees centigrade. So the relationship between the temperature of the source and the type of energy coming, higher the temperatures, okay, shorter the wavelength we will have. Lesser temperatures will have long wave radiations. High temperatures, more high energy, less temperature, okay, less strong energy. So there is a rule for this. You need not remember that. Just know that the relationship between the temperature of the body and the type of radiations the body is radiating out. So when Earth is releasing energy, the Earth is at a very less temperature, the energy coming out will be not as powerful. That's why these energies can be absorbed a bit more conveniently. Okay? And then I gave you an idea about the energies coming from the sun. Sun se aa rahe hain. Okay, this is gamma rays, X-rays, ultraviolet, visible spectrum, infrared, microwave, and radio waves. Such powerful energy, it will not have much much microwaves and radio waves, because बहुत powerful hai. Gamma rays and X-rays, they get absorbed by the Earth's magnetosphere. So what actually Earth receives is this: ultraviolet, visible, and infrared. Okay, so approximately at a height of 800 kilometers from the Earth's surface, okay, the Earth receives three forms of radiations. Earth receives ultraviolet radiations, Earth receives visible spectrum, and Earth receives infrared. The visible spectrum is in the range 0.4 microns to 0.7 microns. Okay. Ultraviolet is less than this, and ultraviolet is absorbed by the ozone layer in the stratosphere, and infrared, ये भी काफी amount होता है. The infrared, however, is not much absorbed. It is largely absorbed by the Earth's surface, and some amount of moisture also absorbs infrared. Pankaj, what is magnetosphere? Okay, I'll try not to look surprised. Earth behaves like a magnet. There's a south pole, there's a north pole, and there is a field of the magnet's influence. Okay, this field is called as Earth's magnetic field, because Earth behaves like a magnet. Okay, so there are magnetic lines of force. There are magnetic lines of force. There are magnetic lines of force. I'm sure you know this. It's just that the term magnetosphere is confusing you. Okay? So this the atmosphere is much smaller. Atmosphere शायद यहीं पर है. ये atmosphere है आपका. The magnetosphere is much larger. So when the solar waves are coming in, the gamma rays and the X-rays get absorbed by the magnetosphere. These are the most destructive. If they hit the Earth, Earth literally will get roasted and cooked. Okay, nothing will remain in terms of life or anything that we know of. Okay? So I said the three energy coming inside the Earth, the three radiation spectrums entering the atmosphere are ultraviolet, visible and infrared. Ultraviolet is absorbed by the ozone in the stratosphere. The visible spectrum is not absorbed at all by the atmosphere. This passes through the atmosphere. We say atmosphere is transparent to the visible spectrum. You cannot block visible spectrum. So this range of wavelength is called as the atmospheric window. For this, it's like a gap. The atmosphere cannot intercept. So this range, the visible spectrum, is called as the atmospheric window of insolation, where the atmosphere cannot absorb this at all. Okay, infrared. Okay, this is partly absorbed by water vapor. Okay, but much of this hits the Earth's surface, and the Earth's surface absorbs it. Infrared is partly absorbed by the water vapor in the lower layers. Okay, but again, much of IR passes through and is absorbed by the Earth's surface. Earth's land, Earth's water, they absorb infrared. Okay, in terms of proportion, these two make up the bulk of the insolation entering atmosphere. Visible spectrum approximately about 42% होता है, and infrared is about 50% होता है. The infrared is a bigger component of the energy entering the atmosphere. जो आपके नोट्स में नहीं है उसको लिख लो, right? You keep staring at me. मेरे आंखों से जाएगा तो नहीं नॉलेज आप में, right? So अगर नहीं है नोट्स में, see, the right technique is, when you come to class next day, carry your synopsis with you. Okay, and as I'm teaching, you keep on revising with me. What you do not know, I didn't tell you, वही ऐड कर लेना. That's the best way of revising. This I have not told you yesterday. And this format, the way I'm discussing right now, okay, these diagrams were different yesterday. So see if you want to add some of this. ठीक है? So approximately, ये भी नहीं बताया था आपको मैंने, at a height of 800 kilometers, okay, which is the boundary of Earth and space. Okay, and it's not same as the Kármán line. Kármán line, some consider Kármán line as atmosphere's boundary, Others say no, the boundary is around this. That's why a lot of calculations of energy is done at this height, not at the Kármán height. Okay? So approximated height of 800 kilometers, the Earth's surface receives three forms of radiations or three range of radiations: ultraviolet, visible, and IR. Visible is not absorbed at all. Therefore, the visible spectrum is called as the atmospheric window of the insolation. The percentage of energy entering the atmosphere, IR is 48-50%, okay, and visible is 40-42% approximately. So, and this percentage is at the height of 800 kilometers. So it's like this is the Earth, the atmosphere. So the energy coming in here at this point, यहाँ पर we have some ultraviolet, we have some visible, we have infrared. At this level, infrared is almost 48-50%, and this is approximately 41-42%. The rest are other radiations along with ultraviolet. So infrared, this was a question in last year's film examination. Infrared is the bigger part of the radiations coming inside, and infrared is absorbed by the water vapor of the atmosphere. Okay? All fine here? Pratish, what was your doubt? Ask me. Anybody else? Offline, any doubts? Can I move on now? Answered your question? Window? Anybody else? Okay, ठीक है. Have a look and let me know if you want to ask me something. Okay, let's move on now. I gave you a quick diagram of the layering of atmosphere, okay, which is, there is a stratosphere, there is, say, troposphere, there is a stratosphere, there is a mesosphere, and there is a thermosphere. Thermosphere. Okay, this is the troposphere. This is the stratosphere, and this is the mesosphere. So before I teach further, I will ask you some questions and see if you understand this. The thermosphere, ये layer में क्या है? Because of strong energy coming in, whatever molecules we have here, they break up into ions. Okay, so this layer has lot of ions. Ions as in plus charge or minus charges. Ions are charged, okay, atoms of some substance. So oxygen hoga atomic form mein. Okay, some nitrogen also can break up. Some helium can break up. Okay, so they're all in the ionic form. Largely, they are in the form of ions. Why are the ions? Because the energy coming in, energy is absorbed here and it breaks the atoms. Okay. So does this layer absorb energy? Yes, it does. Okay. So when the incoming radiation is coming in and it is being absorbed, okay, so which part will be warmer here? The upper part is warmer or the lower part is warmer? So, fine, all of you? When energy coming in and the whatever small atoms we may have, they break up into ions, because of which the upper part is warmer and the lower part is cooler. Okay? So on this x-axis, I am measuring temperature. On the y-axis, I measure height. So the thermosphere mein, the upper part is warmer, the lower part is cooler. So can I draw a line like this? These are the boundaries of the atmosphere layers. Okay. And this white line is the graph of how the temperature varies. Okay. So in the thermosphere, the above part is warmer and the lower part is cooler. Achha. Energy keeps coming in. Energy has ultraviolet, like it has visible, it has infrared. In the stratosphere, there are a lot of ozone particles. There are a lot of ozone particles. The ozone particles, okay, they will absorb the incoming radiations of ultraviolet. So when something is coming in and gets absorbed, okay, now stratosphere will be warm in the above layers or the lower layers. Again, so anything warm from incoming directly, the above layers will be warmer and the lower layers will be cooler. तो इसका line भी ऐसा ही होगा, right? Because coming in, absorb more, becomes warmer. You go down, a bit less absorption. You go down, a bit more less absorption. So thermosphere is also heated from above. Okay. The stratosphere also heated from above. So above layers are warm, the lower layers are cooler. The above layers are warm, the lower layers are cooler. Okay? Between this, say this layer here, this layer is a layer called as X. And there is a layer here, which is the layer called as Y. Which is warmer? X is warmer or Y is warmer? Which is warmer? X is warm or Y is warm? Doesn't matter, all of you. Y is warmer. Because this was warm here, it has had to cool here. Then again this becomes warm, it becomes to cool here. So Y is warmer, X is cooler. Okay? So for mesosphere, which layer is warming? Is X warming mesosphere or is Y warming mesosphere? Okay? Because of which the lower layers will be warmer, above layers will be cooler. Okay, so mesosphere, this is the graph. The lower layer, because mesosphere is heated from below. Mesosphere में ना ions हैं and ना ही ozone है. There's some other gases here. Okay, so mesosphere is heated by the stratosphere. So layers near stratosphere are warmer. You go away, it is going to be far more cooler. All good here? Okay, so UV is gone here. It keeps on coming, keeps on coming. Okay, infrared will start getting absorbed by the water vapor. Where do we have more water vapor? Lower layers or above layers? Lower layers will have more water vapor. Above layer will not have much water vapor. Okay, and the visible spectrum completely goes and hits the surface, warms the Earth's surface, and while going out, okay, the lower layers will have carbon dioxide, water vapor, dust particles, some pollutants maybe, so they absorb. So in the lower layer, the lower layers are warmer, the upper layers are cooler. So graph for this layer will be this in terms of temperature. Ab theek hai all of you? Some people have a proper understanding, sir, ये line ऐसे क्यों बना हुआ है? This line represents the rate of cooling or warming of atmosphere with what? With height, correct. How does ozone helps in getting heated up? Property ozone का है. Ozone has a property of absorbing the ultraviolet. So I have got ozone layers here. So as energy comes in, the energy gets absorbed. I'll have more absorption of ozone here, ultraviolet here. You go down, absorption lesser. The upper parts have more ozone. That's the property of the ozone layer. Ozone is capable of absorbing ultraviolet. Okay? So this line is not a zigzag line for design. Okay, you might think it's a design, But this means temperatures are falling with height. The temperatures are increasing with height. It again starts cooling with height. It again starts warming with height. Why? Because the thermosphere is heated from above. The stratosphere is heated from above. The mesosphere is heated from below. And troposphere is heated from below. Okay. So, ये जो names and troposphere, it's about how the temperatures change with height. So, troposphere will have cooling with height. Stratosphere has warming with height. Okay. Mesosphere again cooling and then again warming. So, draw this diagram if you haven't drawn this diagram. And along with the diagram, okay, right here, इसी diagram में ही you make some points. So, say this is the outer atmosphere यहाँ पर. The energy is coming in, and the energy is largely ultraviolet. It is a visible spectrum, and it is infrared. In the thermosphere, the ions absorb the insolations. So thermosphere is heated from above. The thermosphere is heated from above. Stratosphere has ozone. Okay. Ozone absorbs ultraviolet, and stratosphere is heated from above. The only two ways how the incoming can be absorbed directly: if there are ions or if there is ozone. Pratish, the mesosphere has neither ions nor ozone layer. Okay, so mesosphere ka heating only possible from below. So mesosphere is like a transition layer between stratosphere and the thermosphere. ठीक है? The mesosphere has no ozone. The mesosphere has no ions. The mesosphere is heated from below. Is heated from below. Now in the troposphere, what's coming in is IR and the visible spectrum. Okay. Both IR visible जो है, they both are heating from below. IR is trapped by moisture some amount, so again lower layer become warm. Visible goes directly absorbed to the Earth's surface, and then re-radiation will warm the troposphere. Okay, so IR is somewhat absorbed by water vapor to some extent. The IR is absorbed by water vapor to some extent. The visible spectrum is absorbed by Earth's surface and is re-radiated as long wave radiations. The IR is absorbed by the water vapor to some extent, and the visible spectrum is absorbed by the Earth's surface. The visible is absorbed by the Earth's surface, okay, and is re-radiated as long wave radiations. Roshni, microwaves and radio waves are not a part of insolation. Earth, okay, the sun is very, very hot. So very, very hot sun may, you will not have much microwaves or radio waves. Microwave radios will happen only while there is out radiations happening. अब तो मैंने आपको पहले ही बना के दिखाया. You missed this part of conversation. You joined me late maybe. ये बताया था मैंने. Microwave and radio waves are not there almost. Okay, when they're coming from the sun. The three main components are these: ultraviolet, visible, and infrared. Mesosphere warming by terrestrial? No. Muskan. Mesosphere is heated by the stratosphere, not the radiations coming from the Earth's surface. Earth's surface ka radiations are long wave, so they largely get absorbed here itself. यहां तक पहुंच नहीं पाता. Is it okay, all of you here? Any questions on this? Okay, so now we'll take up the small discussions on this. We start with the troposphere. Start with the troposphere. Yes.
Energy comes from short wave, but IR is reaching the bottom of the Earth's surface, right? So that's a long wave.
नहीं, लॉन्ग वेव ऐसा कोई बाउंड्री नहीं है. Long waves are the ones beyond the infrared. Okay, so microwaves and the radio waves, they're the main long waves. Infrared continues to be like a transition zone. Okay, transition more towards short waves. No. Short wave, long wave is not about distance of travel. Yes. क्यों कह रहे हो? ये कहां सीखा आपने? लॉन्ग वेव का एनर्जी कम होता है, वो लॉन्ग डिस्टेंस जा नहीं पाएगा. शॉर्ट वेव का एनर्जी ज्यादा होता है, इट कैन गो लॉन्ग डिस्टेंसेस. कुछ हिल गया आपका कंसेप्ट. Those are different. टेलीस्कोप से एमिट नहीं करेंगे, टेलीस्कोप पकड़ते हैं. स्पेक्ट्रोमीटर्स में दे कैच दोज रेडिएशंस, बट नॉट टू से कि बाकी नहीं है. ठीक है, दिस इज वन कॉमन मिस्टेक पीपल हैव. लॉन्ग वेव यू थिंक गोज लॉन्ग डिस्टेंस, शॉर्ट वेव्स ओके गोज शॉर्ट डिस्टेंस. ऐसा नहीं है. लॉन्ग वेव को पकड़ना आसान होता है बिकॉज दे आर लेस एनर्जी. शॉर्ट वेव तो पार हो जाएगा. When we are doing the research on space, okay, we rely more on the long waves, but they have to be different type of telescopes which can capture that. अब उसमें भी long waves अलग अलग ranges होंगे. Okay, but know this, that more than radiations, what we know about the outer space is more by what's called as gravity waves. वो फिर एक और concept है. ठीक है. So long waves actually go short distance, and short waves actually go longer distance. Yes, Ashok, correct. Microwaves, radio waves are more a part of the terrestrial out radiations, correct. Fine, all of you here? Okay, let's move on. So I was discussing something on troposphere now. 4-5 points. Point number 1. The troposphere is heated from below. The troposphere is heated from below. Point number 2. IR is partly absorbed by water vapor in the lower layers. IR is partly absorbed by the water vapor in the lower layers, and the lower layers are also heated by the lower layers are also heated by the outgoing terrestrial radiations. The outgoing terrestrial radiations, which are low energy, long waves, which are low energy, long waves. And which are absorbed by the greenhouse substances, dust particles, water vapor, carbon dioxide, and other pollutants. ठीक है? So troposphere is heated from below. Next, there is a linear, means a straight line. There is a linear rate of cooling with height. There is a linear rate of cooling with height. 6.4 centigrade per kilometer. Some may write 6.5 centigrade per kilometer. There's a linear rate of cooling, 6.4 or 6.5 centigrade per kilometer. And what do we call this as? We call this as normal lapse rate. We call this as normal lapse rate. Okay? NLR. The next question to all of you is, in normal, I'm sure all of you have heard about this and you know about this, but what is this? Is this the average value? Is this, okay, maybe the peak value? This is maybe the mean value. ये क्या value है? ये 6.4 ये क्या बताता है हमें? Yeah? Average value, mean value, average value. Abhay, you have read something more. Good, nice. Average, mean is same. Okay, fine. Yes. Okay. ये वैल्यू रियलिटी में है ही नहीं, पूरा धोखा हुआ हमारे साथ पूरे लाइफ. Okay. Whatever we have read is, we never thought about this. This value is a hypothetical value. एक imaginary value है. For what condition? For ideal steady state atmosphere. It is a hypothetical, an ideal steady state atmosphere के लिए this value applies. This value in reality does not exist. What I mean by this? The steady state means a state of balanced atmosphere where whatever comes in is lost immediately. Okay, there's a balance of incoming and outgoing. Reality mein, yes, balance is there, but the balance happens over a longer period. It's like, I earn 10 rupees. I spend 10 rupees. Balance ho gaya? I earn 10 rupees. I save it. Maybe I spend only 2 rupees. Again, I earn 10 rupees. I save. I spend 1 rupee. I again earn 10 rupees. Okay, I don't spend at all. So after 3 months, I've earned 10, 10, 10. The expenditure, however, is 8, okay, 2, 1, 0. Okay, and then 4th month is possible. I earn 10 rupees and I'm spending 40 rupees. Possible there? So the balance happens, but the balance is not instantaneous. Right? If there was a case where the earth was perfectly at balance at an instantaneous condition, whatever comes out will go out immediately. अगर वो होता condition, then we call that as steady state. Reality, the atmosphere is not in a steady state. If it was in a steady state, nothing would happen. Imagine I earn 10, I give away 10. Okay, then I have not saved anything, right? Okay, I buy something only after I've saved enough for myself. So my income is 50 rupees. How do I buy a car of 3 lakh rupees? Because I've saved across months, and then I buy a car of 3 lakh rupees after maybe 6-7 years. So in reality, the atmosphere does not behave like an ideal steady state atmosphere. Agar wo hota, then this would have been the lapse rate. Okay, so this is not the real lapse rate. Remember this. Lapse means what? Fall. The rate of fall is called as lapse rate. So agar ye real value nahi hai, to real value hai kya? Okay, the actual, okay, existing real rate of cooling is called as ELR, environmental lapse rate. NLR is a hypothetical value, imaginary value hai, NLR. But the actual existing real rate of cooling of atmosphere, the real rate of cooling of atmosphere is called as environmental lapse rate. Okay. While the NLR is a constant, ELR is not constant. It varies. Unlike NLR, जो एक fixed figure है, 6.4. In reality, ELR is not constant. It varies. It varies according to seasons. It varies according to nature of the surface. It varies according to day or night time. Okay. So ELR is a variable figure. ELR on the oceans is not same as ELR on the land, is not same as ELR in the summers, is not same as ELR in the winters, and so on. The actual one is called as the ELR. So all the atmospheric process we have is because of ELR and not because of NLR. Okay? All the atmospheric processes are because of ELR and not because of NLR. See, I want you to understand these concepts because the puchega question, now the way they are asking, they'll tweak these terms and ask you questions. The regular ones to aa jayega, you can handle it. But when they tweak these questions, you'll get trapped. All good here? Yes, tell me. Yes, when I say surface ka nature hai, yes, whether forested, whether it is barren land, agricultural land, okay, is it having hard rocks, is it urbanized land? Yes. So the surface nature will decide, okay, what type of ELR we have. The ELR of urban areas is not same as ELR of agricultural fields, or not same as the ELR of the forest. It varies, correct? All good here? Acha. Now, I'll add one more idea here. I won't explain right now, I'll just mention this. Write down. The lapse rate of the troposphere. The lapse rate of the troposphere is the reason why we have weather phenomena. The lapse rate of the troposphere is the reason why we have weather phenomena. The lapse rate makes possible rising air. It makes possible a rising air because the lower layers are warm, upper layers are cold. This warm air can rise up. अगर नीचे का layer cold होता और ऊपर warm होता, air will not rise. Common sense, right? When does air rise? When the air is warm. Air is warm का मतलब है air expands. Air expands, becomes lighter. It will rise up. But नीचे का air अगर cold है, it will shrink. Shrink may become dense. It will not rise. It is the rising air that makes all weather phenomena possible. Okay? You have this point here. The lapse rate of troposphere, and the consequence in terms of rising air, makes the troposphere the turbulent layer. Makes the troposphere turbulent layer. With air mixing, and all the atmospheric phenomena that we see. Okay? So because see, air is warm, air rises, becomes cold, will form clouds and rain down. Air is warm, air rises means कहीं से air घुस रहा होगा फिर. That's what makes winds possible. If air rising very, very fast, the winds become very, very powerful. So be it the cloud formation, be it rainfall, be it the winds, they all are linked to this lapse rate of the troposphere. That's why troposphere is called as the weather layer. This was a question in the GS, paper 1, geography wala question tha ye wala. Why is troposphere the weather layer? The fundamental reason is the lapse rate. And the lapse rate because the atmosphere gets heated from below. And that's possible because visible spectrum gets absorbed and then out radiations happen and the IR gets absorbed by the lower layer of water vapor. All good here? Why is the troposphere the most important, the weather layer? The word tropo means turning. The word tropo means churning going on. So the troposphere is the atmosphere where lot of mixing is going on. And that mixing is what manifests as all the weather phenomena of the atmosphere. All good here? Add a point, I'll come back on this afterwards. Write down. The upper boundary of troposphere is a layer called tropopause. Tropopause. T-R-O-P-O-P-A-U-S-E. Tropopause. Okay. Tropopause. Think of tropopause as a zone of transition. Something has warm, becomes cold, becomes cold, becomes cold, 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 cold. Now it starts to become warm. Becomes warm, 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 less warm, less warm. Okay, sorry. Become cold and starts to become more and more warm. Heating going on. Hits here, it again starts to become cold. So the transition layer, okay. So think of a basic idea. You throw a ball above, okay. The ball becomes slow, and somewhere stops for a moment and then starts falling. यहाँ पे वही हो रहा है. The temperature falls, the fall of temperature stops, and then it starts warming. If the stop hua, that's why it's called as pause. So if I exaggerate this, this is a transition zone where temperatures are falling, it's falling, it's falling. Now there's no fall of temperature, constant temperature, change nahi ho raha hai. Now it starts to warm again. The tropopause is a layer of constant temperature. Okay, don't say zero temperature, it's constant. Constant ka, because see on this graph, I'm showing what? Temperature, right? Say random. This is, say 30 degrees. You rise up maybe somewhere 20 degrees, rise up maybe 10 degrees, rise up 0, rise up -10. Now, -10, -10, -10, -10. Now the warming starts. It becomes 0, it becomes 20, it becomes 40 and so on. So the transition layer, okay, where the fall of temperature stops, that's why we call this as tropopause. It's a layer of constant temperature. There's no change. यहाँ पर एक ही temperature है -10. We also call this as an isothermal layer. Iso means same. Okay, what I'm saying is the boundary of tropopause, troposphere is a layer called as tropopause. The tropopause is a transition layer. लिखा आपने? A transition layer where the fall of temperature is arrested. Where the fall of temperature is arrested. And the layer maintains the same temperature. And the layer maintains the same temperature. Therefore, it is also called as isothermal layer. It is also called as isothermal layer. Okay. So I hope you understand why I'm calling this as tropopause and why I'm calling this as isothermal. When I say pause, what is pause? What is stopping? What's falling? The change of temperature stops. And when I say isothermal, I mean it has the same temperature, constant temperature. Now this layer acts like a lid. Okay. It will not allow the air to escape and come here. यहाँ पर फंस जाएगा. Imagine this. This is some balloon packet. This is the air outside. The air outside. Outside air, random numbers, okay? Outside air is, say, 30. It becomes 20. It becomes 10. It becomes 0. It becomes -10. It stays -10. Stays -10. This balloon here is also at 30. It rises up. Okay. This also cools. It cools and it becomes 25. 25 is warmer than 20. Still warm. It'll again rise. It'll come here. It'll cool to become maybe 12. 12 is warm than 10. It'll again rise. It'll come here. It'll become 2. 2 is warm than 0. It'll again rise. It'll come here. This also cools. Maybe it hits -10. -10. Okay. Up ye or rise because -10 यहाँ पर है, भाग -10 है. Same temperature. It won't rise. Same temperature. Okay. So for this layer, the balloon will not go any further above. Right? Anything rising is because of difference of temperature. When the packet of balloon is warmer than the air outside. Okay. This is cooling and the balloon also is cooling. It's a mechanism. I'll come back afterwards on this. You just know, because there is an isothermal layer, okay, the balloon will no longer rise. It is trapped inside this. Okay, so the isothermal layer essentially acts like a lid. देखो आप, the isothermal layer acts like a lid and won't allow the and won't allow for the air to rise further and escape into the stratosphere. It acts like a lid and won't allow for the air to escape, to rise further and escape into the stratosphere. This is another reason why all the weather phenomena remain within the troposphere. Another reason why all weather phenomena remains within the troposphere. What I'm answering is, why do we have weather in troposphere and why all weather remains trapped in the troposphere? Why do we have weather? Because there is a lapse rate. Why it remains trapped? Because of an isothermal or a tropopause. These two things together make the troposphere the main weather layer. देख लेंगे आप all of you now, question हो जाएगा. This was a answer to why is the troposphere called the weather layer. लिख लो question. Why is the troposphere called the weather layer? It was a GS question. I think 22 में या 21 में, I forget the year. You can go back and look. Why is troposphere called the weather layer? Any questions? And when I say weather, I mean clouds, I mean winds, rainfall, humidity. Okay. I also imply whatever temperature variations we have and whatever pressure variations we have. Sab milakar, it becomes the weather phenomena. Weather means there are cyclones. Weather means there are tornadoes. Weather means there are sandstorms. All of this happens only inside the troposphere. All good? Okay. We move on now. Next, we talk about the stratosphere. The stratosphere. Okay. It has lapse rate inversion. It has lapse rate inversion. Okay. Lapse means what? Fall. Okay. Lapse rate means fall of temperature with height. When I say inversion का मतलब क्या है? Rather than fall, it starts to increase. That's why it's also called as an inversion layer also. The stratosphere is the layer of lapse rate inversion, or it is also called as simply a high level inversion of atmosphere. It's also referred to as high level inversion of the atmosphere. Okay. Next one, stratosphere. Stratosphere is heated from above. Stratosphere is heated from above. Next, it is heated by ultraviolet absorption of ozone, by ozone. Is heated because of ultraviolet absorption by ozone layer. Ozone layer होता कहां पर है? Okay. So write down. Ozone is present from about 15 kilometers above surface to about 40 kilometers above surface. To about 40 kilometers, 40-50 kilometers above surface. But it is maximum in but it is maximum in 25-30 kilometers above the surface. Above the surface. Achha, I forgot to mention the heights here. I'll come back again for that. But just know that ozone starts about 15. So somewhere here is say 15. So around 15 se lekar, okay, this height is about 50 kilometers. Okay, तो यहाँ तक पूरे में ओजोन होता है, but the maximum ozone is in this belt here. At around 25-30 kilometers, the maximum होता है. That's why the above layers are the warmest. The lower layers are a bit less warm. Okay, so the stratosphere is heated from above because ultraviolet gets absorbed by ozone. Ozone in general is found between about 15 to about 40-50 kilometers, but the maximum is found in around 25-30 kilometers. Right down. The stratosphere does not have much mixing of air. It does not have much mixing of air. इसीलिए ना यहाँ पर air layers. See, when will you have layers? When the mixing is good, or when the mixing is not good? Not good, right? If there's mixing going on, the layer hoga nahi. But when the mixing is not there, then there are specific layers. The stratosphere will not have much mixing. That is why there are layers, and hence called as stratosphere. Strata, layers. The atmosphere does not mix very well here, and the layers can be distinct in terms of their locations. However, stratosphere does have very strong winds called as stratospheric winds. It does have very strong winds called as the stratospheric winds. ठीक है, यहाँ पर मिक्सिंग बहुत कम है, but very high speed, okay, winds we have. These winds can carry ozone with them also. Okay, let's say down. The stratosphere has some amount of moisture. Which can form clouds. But those clouds do not cause rain. Cause a rainfall. They are like dead clouds. इतना भी नहीं है कि यहाँ पर rainfall हो जाएगा. There are some clouds, but they are dead clouds. So we call these clouds as, because they're dead clouds, we call them as nacreous clouds. Necro means dead. They're called as nacreous clouds. Nacreous. They're called as nacreous clouds. And importantly, they are very bright. They're very bright. And hence also called as mother of pearl clouds. Also called as mother of pearl clouds. Mother of pearl is very, very bright. Okay. They are like pearls, but very, very bright, very white in color. So they're nacreous clouds because they don't cause rain. And because they're white, they're called as mother of pearl clouds. You find them in the stratosphere. Okay. And add a point here. The stratosphere has continuous formation and destruction of. It has continuous formation and destruction of the ozone. Okay, part of process called as the Chapman cycle. या बन रहा है टूट रहा है, बन रहा है टूट रहा है, right? Continuous formation and destruction of ozone, which is called as the Chapman cycle. Okay. Next, the mesosphere is a transition zone. Meso means beach mein. The mesosphere is a transition zone. It neither has ions nor does it have ozone. It neither has ions nor does it have ozone, and therefore is heated from below by the warm layers of upper stratosphere. Is heated from below by the warm layers of the upper stratosphere. तो इसमें फिर लैप्सेट होगा. Okay, this is the warmest one. You rise up, it will now become cooler. But the lapse rate has another value. You can ignore that. Okay, just know that is a transition layer. It's heated from below. एक add करो point. The mesopause, just as we have tropopause, we will have a stratopause and we have a mesopause. The mesopause or tropopause or the stratopause, all the three are layers where the temperature increase or fall stops. Okay, so all the three are isothermal layers. Remember this. The mesopause is one of the coolest layer of the atmosphere. Is one of the coolest layers of the atmosphere. At a temperature of about -90 to -100 centigrade. It is the coolest layer, the least temperature, at around -90 to -100 centigrade. Comparison within bracket it down. The tropopause has a temperature of around, -60 to -70 centigrade. -60 to -70 centigrade. All good here? Now come towards the thermopause. The thermosphere, sorry. Come towards the thermosphere. Okay. So thermosphere has ions. The thermosphere has ions. Therefore, it is synonymous with the ionosphere of the atmosphere. It is synonymous with the ionosphere of the atmosphere. Mesopause is -90, Palak. So some people ask, sir, thermosphere तो यहाँ पर है, ionosphere कहाँ पर है? Ionosphere thermosphere ही है. When I use the word ionosphere, I'm talking in terms of the composition. When I use the word thermosphere, I'm talking in terms of how the temperature changes. This layering is in terms of not composition. It's in terms of the temperature patterns. So thermosphere को ही ionosphere बोलते हैं. ठीक है? Thermosphere is heated from above. Thermosphere is heated from above. The above layers are warmer than the lower layers. The above layers are warmer than the lower layers. However, while the thermosphere can have very high temperatures, the thermosphere can have very high temperatures, it has negligible heat. It has negligible heat. So some of understand this, others. Temperature is what? Temperature is a measure of relative hotness or relative coldness. Okay. When I say heat, this is the energy. They are not same things. Some bodies can have less energy, but they can show very high temperatures. Some bodies will have, okay, very high amount of heat, but will show less temperatures. For example, you take a stone and you take a bucket of water. If we heat them, you'll find stone becomes very hot. But you leave the stone for some time, the stone also becomes very cold very quickly. Because stone is not capable of absorbing lot of heat. उसका property वैसा है. Water will take a lot of time to boil. Okay. Water may not feel as hot, but water has more heat. Okay. So some things can have high amount of heat, but it has low temperature. Some things can have a low amount of heat, but can record higher temperature. ये दो अलग चीज है. Heat is the energy. Temperature is a measure of how hot or cold. Hot, cold is not about energy alone. So we have a formula where heat is equal to mc theta. Theta is the temperature, C is the specific heat property, and m is the mass. ये formula है of heat. Some bodies can have very high temperatures, but अगर mass बहुत कम है, the heat will be less. So thermosphere has high temperatures, but it's very rarefied, no? Hardly any molecules in that. The thermosphere does not have too much of, okay, heat in it. Exactly, oceans में. In oceans, it might not feel very warm, but oceans can absorb a lot of heat. Okay, this is a formula, a very basic one. Okay, mc theta, mass. This is the property of the body called specific heat. Okay, like water has very high specific heat and no temperature. Look right now, the thermosphere is extremely rarefied. That the thermosphere is extremely rarefied. It has very less molecules. It has very less molecules. Remember, 99.9 atmosphere खत्म हो जाता है by 40-50 kilometers. So what I have in thermosphere is very few molecules, and hence the mass is very less. The mass of the thermosphere is very less. Hence, thermosphere has very less amount of heat energy. It has very less amount of heat energy. ठीक है? One more fact. As ionosphere, there are different layers. As ionosphere, the thermosphere has different layers. There is a D layer, there is a E1 layer, E2 layer, there is an F layer. As an ionosphere, there are different layers. D layer, E1 layer, E2 layer, F layer. You also have a G layer. जो D layer है, these are all layers of ionosphere. The D layer is present only in the daytime. Remember D and daytime. In the night time, it disappears. In the night time, it disappears. The D layer is useful for very long wave radio communication, but not good for nighttime communication. The D layer is present in the daytime, it disappears in the nighttime, and it's used for a very long wave radio communication. But ये बहुत reliable नहीं है because night में disappears. E1 layer is also called as the Appleton, it's also called as Kennelly heavy side layer. E1 is called as the Kennelly, N-N-E-L-L-E-Y. It's called as Kennelly, K-E-N-N-E-L-L-E-Y, Kennelly heavy side layer. This can reflect medium waves of radio communication. F layer is called as the Appleton layer. And the Appleton layer can reflect back shortwave communication, shortwave of the radio waves, not shortwave in general nahi. This can reflect the short wave of the radio waves, medium wave of the radio waves. So radio waves में variations हैं. Some radio waves are longer and some radio waves are shorter. But ultimately है long wave ही हैं दोनों. हाथी का बच्चा छोटा होकर बड़ा ही रहेगा, राइट? ओके, तो ये छोटा होकर लॉन्ग वेव ही है. ओके, दिस ऑल्सो इज लॉन्ग वेव. FM is different. Okay, the frequency modulation ones are different. All fine here? So one point likho right down here. The ionosphere plays a very important role. The ionosphere plays a very important role in radio communications. In radio communications. Why? Why? Because Earth is a curvature. I have a transmission center here. The person must receive here. Because curvature, how will it go directly here? So I need atmosphere. Atmosphere will reflect it back towards the receiver. So this transmission from the ionosphere, it gets again reflected. Either use this, or maybe you have a satellite here. The satellite can reflect this. So before we had satellites, okay, we depended entirely on the ionosphere. Okay, I've used Appleton layers. We have used heaviside Kennelly layers, okay, for communication of, okay, using short wave, long wave radio waves. Because Earth is a curved surface, a sphere. Now, what I forgot to mention is the relative height of the atmospheric layers. Okay, so the troposphere, this is at the poles. The height is about 6 to 8 kilometers. At the equator, it's about 16 to 18 kilometers. Then we have the stratosphere till about 50 kilometers. Then we have mesosphere till about 80 kilometers. Okay, and the temperature lapse rate falls, increases, falls, and again increases. So I forgot to mention these values. लिख लो अभी आप. The lowermost layer is the troposphere, the stratosphere, the mesosphere, and the thermosphere. And the thermosphere also is the ionosphere. Yes, the aurora borealis and australis, they happen in the ionosphere, correct? When the magnetic flux or lines, they interact with the ions. Yes, Kaushal, correct. So 6 to 8 kilometers, 16, 18 kilometers, 50 kilometer height, 80 kilometers, and this goes on up to 800 kilometers. Thermosphere goes on up to, and somewhere here, you may call this as the Kármán line at around 100 kilometers. Most aircrafts fly in this range. Okay. Something called jet streams होते हैं यहीं बहुत, and some higher jets can go up till here. Beyond this, we call this as, for flight purpose, we call this as outer space. Why this difference of height? Why is the troposphere higher here and less high here? Because here it's very cold, air sinks. And here, convection, the air pushes the boundaries a bit higher. Write down. Beta, no scales. रखो side में. All drawing freehand में. No scale, no protractor, no rounders, nothing. Okay, freehand, trust कि वो सीधा लग रहा होगा. That's about it. Write down. The troposphere is for a lesser height at the poles, and the troposphere is at a higher height at the equator. At the equator. Why? Because at equator there is convection. Air is rising rapidly, which pushes the troposphere to higher heights. Which pushes the troposphere to the higher heights. All fine here? Yeah, so for flight purpose, we can say the space starts from 100 kilometers. But if we look at the atmospheric processes, we say the space starts after 800 kilometers. Okay? So know these values. And second, now you know there are transition zones between the layers. This is the troposphere. This is, tropopause. Tropopause, this is the stratopause, and this is the mesopause. So tropopause mein temperatures are about, I said, minus 60, minus 70. This is the coldest layer, minus 90. All the three are isothermal layers. So it becomes cooler, cooler, cooler. Yahan par there's no change, it becomes warmer. Again, no change, it again becomes cooler. Again, no change, it again rises. Okay? The tropopause, the stratopause, and the mesopause. All the three are isothermal layers. So the location of the isothermal layers is what tells us the layer of atmosphere has changed. This itself can be about 1 to 2 kilometers. The thickness of this layer can be 1 to 2 kilometers. All good? Achha, just go back to the mesosphere wala list likha tha humne. Just go back to that page, all of you. I forgot to mention one fact. Write down. The mesosphere, jahan likha hai mesosphere, just one sentence add karo. The mesosphere can also have some water vapor and clouds. बहुत कम होता है. The mesosphere can also have some water vapors and clouds, and they're called as noctilucent clouds. They're called as noctilucent. Nocti as a nocturnal, raat mein. This means shining. Okay. Luminance, lucent. So these clouds, they shine in the night time. They can have some clouds, but they will not cause rains. They're called as noctilucent clouds, and they shine in the night time. So what are nacreous clouds? What are mother of pearl clouds? And what are noctilucent clouds? When I go towards the clouds a bit more, we'll talk about what are cirrus clouds, what are stratus clouds, the different names of clouds we'll have. Okay? So your most important part of atmospheric arrangement is this one, the layering in terms of the temperature properties. Try that, Pankaj, it'll be nice. If all of this you can summarize into one diagram. Okay, that's the best synopsis. It's possible. I can draw this, no? I can draw this and I can write down some properties here itself. I can draw this, write the properties, yahi pe likh lo, properties. Yahi likho properties. You can summarize the entire discussion of temperature patterns into one diagram. Do it. Okay. Now take a fresh page and write down the heat budget of Earth atmosphere. The heat budget of Earth atmosphere. These topics, they don't have too many questions. But without these concepts, many other concepts you can't apply or understand. Okay, it's like a base concept you must know. Okay, now, what's the meaning of budget? Budget is a statement of what comes in, what goes out. We can have budget for a country. We can have budget for a house. What's my income? What's my expenditure? For the country, what are revenue sources? What's expenditure? So anything which has a list of what comes in flux and what goes out flux, that's called as a budget. Essentially what we're doing is, we are trying to understand how Earth manages and Earth regulates its heat and temperature. हमें ये समझना है. So the fact is, the Earth is not getting hotter every day. I mean, leave aside global warming. That's an anomaly. If I forget global warming, we know Earth has been in balance. Even if when we have ice age, you're talking about ice age, right? Astronaut thought the Earth had become very, very cold. Ice age means the temperatures are 3, 4, 5 degrees below the normal. It's an ice age. So more or less we say, even if I account for the ice age, the temperatures of the Earth has not changed much. And Earth has been receiving energy consistently over the millions of years. कोई mechanism होगा ना, where Earth can receive and also Earth gives out. Otherwise, like I said, if Earth was only receiving, Earth would have exploded. If Earth was only losing, Earth would have become freezing cold beyond what life could have been possible. There's some mechanism by which the Earth is balancing itself. So we are trying to understand how Earth manages and regulates its heat and temperature. Okay. Ignoring climate change of our times, Earth has maintained its temperatures. Okay. Approximately we say, okay, 15-16 centigrade hai Earth's temperature on an average. Okay, so what's heat budget? It's a way of understanding how Earth manages and regulates its heat and temperature. Likho, write down. It's an attempt to understand how Earth manages and regulates its heat and temperature. Ignoring climate change of today's time, okay, Earth has maintained its temperature, maintained its average temperature of around 15-16 degrees centigrade. This means while Earth consistently receives solar radiations, Earth is also losing energy continuously. While Earth is continuously receiving energy from the sun, Earth is also losing energy continuously. Okay. This is what's called as Earth atmosphere system behaves like a very efficient heat engine. It behaves like a very efficient heat engine and as an efficient black body. Earth and atmosphere, it behaves like a very efficient heat engine. Anybody knows what's a heat engine? A system that receives heat, does some work, and then releases the surplus heat. Is called as an heat engine. ये अर्थ करता है, Earth takes energy and Earth does work. Winds are moving, currents are moving, plants are growing, trees grow, we have respiration. So all this is work of the Earth. The rivers are running. Okay, we have some processes of erosion, denudation. So Earth takes energy, it does some work, and Earth releases energy also. And we say Earth is a very efficient one. Plus, it acts as a black body. Black body is any body that receives energy and gives out all the energy. Okay. Otherwise, Earth, like I said, would have become progressively hotter and hotter every second. ऐसा होता नहीं है. Okay. So there is a mechanism by which Earth is receiving solar radiations continuously and Earth also losing energy continuously. तो ये पढ़ने के लिए I have a mechanism or we have a method called as studying Earth's heat budget. Black body. Black body is any body that receives energy and that gives off energy also. It will not absorb forever. It's a black body. So Earth heat engine भी है और Earth black body भी है. ठीक है? Now see, when we study how anything comes in and how anything goes out, there are two ways of studying this. Okay, one is in terms of cycles. We have life cycle. One is born, one grows, becomes mature, becomes old and dies. And again something else is born. So this is a diagrammatic pictorial depiction. We have a life cycle of a butterfly. Okay, there is a butterfly, it lays eggs. Okay, it has larva, it has pupa, cocoon or whatever. Again it dies and then the cycle continues. So cycle is one method. Cycle is more of a pictorial method. You can visualize this. How does, okay, carbon dioxide cycle? You can show a diagram, right? There is a land, there are forests. Okay, it gets released, gets absorbed, back to earth. Again, the plant releases. ये जो pictorial depiction है, that's called as a cycle. So we have hydrological cycles. Water is cycling. We have gaseous cycle. We have got rock cycle. We have got phosphorus cycle, life cycle. The cycle is a way of visualizing how things are moving. The other way is budget. Budget is a statement. ये एक diagram है. Okay. Budget क्या है? Budget is a statement. Statement क्या होगा? There will be tabular form. Okay. Influx. 1, 2, 3. Add up together. इतना अंदर आया as revenues. Outflux or expenditure. 1, 2, 3. We are lost and this is my outflow. And we show they may or may not be equal. So budget can be a surplus budget, more revenue, less expenditure. The budget can be deficit budget. I've got less revenue, more expenditure. Okay. So when I see some incoming, outgoing, in terms of a pictorial thing, I call that as cyclic representation. When I show it in terms of a table or a statement, I call this as a budget. Okay, so we are studying the energy budget of the earth, how energy comes in and how energy goes out in terms of a mathematical. Ye mathematical nahi, remember, this is all pictorial. This is more qualitative. This is more quantitative. इसमें mathematical expressions होंगे. ठीक है? So 2 lines on this. The heat budget is a quantitative mathematical statement. It's a quantitative, it is a mathematical statement of how energy comes in, within bracket, how much and by what mechanism. How energy comes in, how much and by what mechanism, bracket closed, and how energy is lost or how heat is lost. Again, how much we are losing and by what mechanism. That's your heat budget. So heat budget is a way of appreciating how does Earth manage its balance. Okay? So one sentence here. The heat budget therefore is a way of appreciating how Earth maintains its energy and heat balance. Its energy or heat balance. Take all of you all fine here? So for heat budget, I will have the statement on influx, कैसे अंदर आया, and we will have a statement of outflux, how we are losing heat. Right, next point लिखो आप. For heat budget calculations, we consider the atmospheric boundaries at around 800 kilometers. At that height, the solar energy received by Earth, by Earth atmosphere system. At that height, the energy received by Earth atmosphere system, okay, is approximately 1.99 calories per meter square per minute. The amount of solar energy received by the Earth atmosphere is about 1.99 calories per meter square per minute. We call this as the solar constant. इतना energy आता है. It's called as the solar constant. And this energy is entirely short wave radiations or short wave and high energy radiations comprising ultraviolet, visible spectrum and infrared. Comprising ultraviolet, visible spectrum and infrared. So agar, again, this is the surface ये बाउंड्री ऑफ द एटमॉस्फेयर है 800 किलोमीटर अबव द सरफेस. The energy coming in here, okay, this is the solar constant, and this has ultraviolet, visible spectrum, and IR. Okay, this may be considered as 100% insolation. Okay, ये जो energy आ रहा है, let's assume this is 100 units. It's about 100, say you don't want a percentage, say 100 units of, okay, energy. इस energy के साथ 3 things can happen. One is, some comes in and the atmosphere absorbs it. Some energy is reflected out from atmosphere, dust particles and molecules, from clouds reflected, or also reflected from the Earth's surface. Now, the insolation, okay, can witness, or insolation witnesses the following three processes. Number 1, absorption by the atmosphere. Absorption by the atmosphere. ये कौन सा वाला होगा component? This will be what? Ultraviolet. Absorbed by the ozone of stratosphere. So I said that what's coming in, 3 things can happen. One is atmospheric absorption. Put hyphen. For ultraviolet, absorbed by the ozone of stratosphere. The ultraviolet absorbed by the ozone of the stratosphere. Okay. Equal to 15 units. Yep. And how we know this? So they have worked out on that. We don't bother about that part. Okay. So one thing is, what comes in, the atmosphere absorbs, is one. Number 2, reflection and scattering from clouds, dust particles, ice crystals, and Earth's surface. Reflection and scattering from clouds, from dust particles, from ice crystals, and the Earth's surface with its land, forests, and water. Okay? So there is some reflection from dust particles and ice, some from the clouds, and some from Earth's surface. Water bhi hai, land bhi hai, forest bhi hai, reflecting back. Okay. This is called as the albedo, ALBEDO. It's called as the albedo of the Earth atmosphere system. It's called albedo of the Earth atmosphere system. Equal to 35 units. So 15 जो है clouds में absorb हो गया. What goes back is 35 units. Okay. The third component is it comes and gets absorbed by the Earth's surface. Third component is, okay, the insolation is absorbed by the Earth's surface. ये कौन सा वाला होगा? It will be visible spectrum and some amount of infrared. The spectrum that directly gets absorbed by the Earth's surface. The visible spectrum and, okay, some amount of infrared. This is about 50 units. तो अब ये याद रखेंगे. Okay. 100 is what comes in. Okay. 15 absorbed by the clouds or by the stratosphere, atmosphere. 35 is reflected back. The reflection is called as the albedo. Albedo of clouds अलग होता है. Albedo of water अलग होता है. Albedo of land अलग होता है. Different from forest. Altogether, it is 35. What remains is 50 is absorbed by the Earth's surface. So, Earth's surface is heated by how much? 50 units or 50% of the insolation. All fine here? Okay. Now, this 50, this is the influx. So, do one thing. If I have not drawn this, draw this. So, atmosphere boundary hai. This is the insolation coming in. This is 100 units. This includes UV, visible, and infrared. This is largely a short wave and it is a high energy. Iska ek component is absorbed by the atmosphere. Absorbed by atmosphere. ये 15 units हैं, and this is the ultraviolet by the ozone of the stratosphere. Then we have some reflection from the clouds, reflection from ice crystals and dust particles maybe, and some reflection from the Earth's surface. ये तीनों मिलाकर, all the three together, this is the albedo of the Earth atmosphere system. This is called as the albedo of Earth atmosphere system, and this is about 35 units. And then we have one coming in straight, and it is absorbed by the Earth's surface. This is 50 units. If you have not drawn this, draw this. Three things happening to the insolation. One, absorption. Two is albedo. And three, absorption by the Earth's surface. Rajneesh, I'll discuss that afterwards, not now. All good, all of you? Chalo, that's for today. And with a heavy heart, I will miss you tomorrow. Okay. You also try not to feel too upset. We'll continue day after tomorrow. And make sure you have done the summary work on daily basis. Yesterday, I think we had a session on glacial landforms. Syllabus में नहीं है, but they do ask questions. And today, I think he will discuss some case study today, not landforms. So 2:15, join back again. 15, 2:15, 1-5. You have a link on your dashboard. Okay, bye-bye.